Hello friend, how are you? I hope everyone is fine. So today I'm going to discuss about the nuclear magnetic resonance spectroscopy. Nuclear magnetic resonance spectroscopy technique detects the energy absorbed due to changes in the nuclear spin states. Okay. So if you will study this note, it will be very easy to understand. Okay. NMR spectroscopy reveals information about the number and types of proton and carbon and also other elements like nitrogen, fluorine, etc. Okay, present in the molecule. The phenomenon of NMR spectroscopy is similar to that of the visible spectroscopy. In visible spectroscopy, the absorption of a photon by an electron causes the electron to move from its ground state orbital to a higher energy level orbital in the excited state. One thing the why it is very many time in examination they asked that why NMR spectroscopy different from other spectroscopy. It differ from other spectroscopy in some respect as well. That's the firstly the external magnetic field is required for the generation of the ground and excited NMR states, while in case of other spectroscopic phenomenon no such magnetic field is required. Okay, so this is the requirement, very important distinction of the NMR spectroscopy. Okay, and secondly lifetime of excited state in the NMR spectroscopy is about the 10 to the power 9 times longer than that of the other electronic states. Okay. The nuclear spin transitions in all forms of spectroscopy. It is necessary to have two or more different states of the systems that differ in energy. Okay. Okay. If you will study that, it will be very understandable, I think. In presence of an external magnetic field, the protons respond to the influence of the external magnetic field and tend to be align itself with the data field. It is very important to be remembered if you will going to study the nuclear magnetic resonance. So it is very important for you. So it is this diagram many times asked, this diagram, because what the splitting of spin state in presence of magnetic field or absence of magnetic field, many times in examination they can ask. Okay, so student, you have to remember this diagram, basically B.Sc students. If a proton is processing in an aligned orientation, it can absorb the energy and pass into the opposite orientation, which is subsequently loses the energy and relaxed back. Okay. So why it is termed as a nuclear magnetic resonance? This is the definition I have also given. Theory, about theory, it is very important. Theory, I think it will be very Larmor frequency, it is also important, so that spinning nucleus and exception for the processional frequency, it is very important. Is mu n is equal to nuclear angular momentum into gn to by 2 mp. That means and this value many times the value is given, but you have to remember also, because the gn, the magnetic gyretic ratio, it is 5.585, and also the mp is nothing here, it is mass of proton. Okay, so beta n is equal to eh by 4 5 mp, where beta n is a constant. Okay, the beta n nuclear magneton, known as a nuclear magneton, and for proton, its proton is one hydrogen, its value 5.051 into 10 to the power minus 27 joule by temperature. So equation becomes this. Okay, let's and this is also important. The V will increase with increase of magnetic field. Okay, and Mi, it is a magnetic spin hoy. From the above the V is equal to, it is a nothing, a potential energy G and Bn Btn and ml b naught. So for mi, for half minus half, it will be becomes the minus half Gn Bn b naught. Okay, because it have a one minus already. So for plus half it become minus half Gn Bn b naught, and for minus half it becomes the plus half Gn Bn b naught. The energy difference between two levels is given by del A is equal to V half minus V half, already becomes Gn Bn b naught. Okay, it will find the energy difference between the two spin state of a proton. It will be, it was given in the last 2016 of Guwahati University. This question asks a proton NMR spectrometer output with a radiation of frequency 100 megahertz find at what magnetic field a free proton will show resonance given that the values of nuclear magneton and the nuclear Z factor are 5.05 into 10 to the minus 27 joule T inverse and 5.585 respectively. So it is given answer, the solution is given. So if you will study then you will be understandable. Okay, it will also important calculate the precessional frequency of a proton. It is very important, it is very easier. Calculate the magnetic direct ratio, it is also the put the value in the formula. Okay, NMR active and NMR inactive nuclei, it is very important, so we have to concern. Okay, zero nuclear spin, integral nuclear spin, and also a half integral nuclear spin. Okay, and this question given the predict the which of the following nuclear NMR active or not. So solution I have already given. Instrumentation, it is also important, sometimes asked in exam. So basic requirement of typical spectrometer are block diagram NMR spectrometer, solvent in NMR. Basically CCl4 and CDCl3, CDD means deuterium. So it is common solvent for, actually generally deuterated solvent are used in NMR spectroscopy. This is main reason for using deuterium solvent are the, it is during analysis much more solvent is used than the substance of interested in the sample of this investigation. If proton H is present in the solvent, then absorption will be more than sample itself. So NMR spectra will not give much information about the sample. Okay, and then second option is also that shielding effect, deshielding effect. Oh, you will be, you have to know it, because for study about chemical shift, you have to know about the shielding deshielding effect. I hope you will be understand when you will study these notes. So it will very simply I have explained. The example also I have given. And this question many times asked that why tetramethyl silence considered as a referred compound is many times asked. So it is very this answer is that it can easily be removed from sample by evaporation due to the volatile properties. Okay, its resonance peak occurs at a higher field than almost all organic protons. Okay, so and also it gives this single sharp absorption peak as its 12 protons are in the sample chemical environment. Okay bro, explain why tetramethyl silence is used as a reference in I have already told you. So equivalent and non-equivalent proton, this the many time asked many times in every examination related to the NMR spectroscopy. One question is common for equivalent and non-equivalent. Okay, think it is also important the n+1 rule, the Pascal's triangle. Okay, n+1, the one refers n refers the neighbors hydrogen. So singlet, doublet, triplet, quartet, quintet, and sextet and septet. So chemical shift. Okay, chemical shift may be defined as the shift in position of NMR absorption of a particular proton in a molecule with respect to a signal of reference compound. Okay, the knowledge of chemical shift help one to know about the electron density around a proton. Okay, when a hydrogen nucleus is surrounded by a high electron density, the proton experiences a lower magnetic field due to the shielding effect. Okay, the example also given here. So it is the effect of chemical shift. Electronegativity is most important. Several factors which on uh, chemical shift depends. Okay, electronegativity one, then the hydrogen bonding, next an anisotropic effect. So okay, thank you for watching, and chapter 2 for NMR spectroscopy I will obviously send.